Hello and welcome to another video for CIS 232 Unix shell scripting. This week we're going to begin writing our first scripts. If you want to follow along, you'll need to begin by setting up your scripting environment. Open up your text editor and a terminal window and position them so you can see both of them on the screen at the same time. I'll begin by creating a directory for my scripting projects this semester. I'm going to create mine right here in my home directory, so I'll type mkdir scripts in the terminal and then set it as the default using the cd command. Now I'm ready to start writing my first script. I'm going to switch over to the text editor here, and the first line of a Linux script identifies the program that will be used to interpret the script. We do this by writing the number sign, shift 3, and an exclamation point. This combination is usually spoken as #bang, followed by the path to the program. In this case, and for most of the semester, we want our script to be interpreted by the bash shell, so we'll write /bin/bash. The hash character is also used to write comments in scripts. So on the next line I'm going to write a few notes about what the script is supposed to do, who wrote it, and when it was created. When we go to run our script, the bash interpreter will skip over any lines that begin with that hash character. So we can write whatever we want there. Comments are there for the people who might read your script, not for the computer. I want our first script to be something useful, so I'm going to create a script that will look for any executable files in my current directory or any of its subdirectories. I'll write a note to that effect and also make a note that I wrote it in January of 2015. At this point, I'm going to save my script in the directory I created earlier. Make sure here that you are saving it in the right folder. I named mine findexec.sh. Linux files don't require extensions, but it will make it easier to identify which files are scripts, and it'll keep you from having problems uploading the files to the class website. So we will use that .sh extension on all of the scripts that we write. The class website won't accept files without extensions, so do make sure that you provide an extension for your files. Notice that when we save our file, our text editor changes the color of the lines we've written. It uses that first line to recognize what kind of file it is, that it's a bash script file. And so then it uses a feature called syntax highlighting. So any comments are going to show up in blue. Other types of special words or characters or lines will show up in other colors, as we'll see shortly. That first line, because it's the line that identifies the file type, also it automatically gets bolded so that that one stands out as well. I'm going to leave a blank line after my comments. Blank lines get skipped over as well when the computer goes to interpret the file, so we can put blank lines anywhere we think it would be helpful for us to be able to read it. And then I'm going to write a command that will just print some text to the screen that is going to be helpful for my user when they run it. So I'm going to use the echo command, and then in quotation marks I'm going to just write that this script a little note that says executable files in the current directory, and actually I'm going to say and its children. And then I'm going to go ahead and save this again. I'm just going to use a keyboard shortcut this time, so I'm not going to press the save menu. And I'm going to come back over to my terminal and actually run the file. So I need to make it executable first using the chmod command. Which it would help if I spelled it correctly. And then I'm going to execute the script by typing / and the name of the script. The / is necessary. Linux will not look for files to execute in the current directory by default. That's not part of the search path. And so that / just tells us I do want you to execute something that's here in the current directory. So if I type /findexec.sh, it says executable files in the current directory and its children, and just prints out that text to the screen. Notice that it doesn't print anything from any of the comments. Those are purely for the person reading the file. It just skips over it when we actually go to run it. Now I'm going to go back to my script and add some more lines to it. This is a process that you'll do continuously as you develop a script. Write a few lines, test it out, write a few more lines, test it out, etc. I'm going to use the find command back here in my text editor to look for the executable files. The find command is a powerful and useful utility. I'm not going to go into the details of how it works in this video, but I recommend you look it up in your textbook or in the Linux man pages. The important thing to note here is that any command that can be run in a normal terminal window can also be executed inside a script. To find the files we're looking for, we'll use the command find dot space, or find space dot space dash perm dash u plus x space dash type space f. So this is telling the find command, look in the current directory for files that have a permissions that are set, that are executable by the user, and that are of a type of a normal file, so as opposed to, say, directories. After we've added this line, I'm going to save it, and I'm going to test out my script again over in my terminal window. So now it says executable files in the current directory and its children, and it also lists /findexec.sh. So it recognized this as an executable file. That's good. That's what we'd expect it to do. I am going to create another non-executable file in this directory, so I'm just going to say touch space another file as a terminal command, and then run my script again. So we're testing to make sure that it's listing the executable files, but not files that are not executable. It's always a good idea to test scripts with as many different situations as you can. So we want to actually try out several different test scenarios. So this script is useful as it is, but we can make it better. Instead of always starting the search in the current directory, let's make it so that the user can specify which directory to search. We'll do that by using what's known as a positional parameter. This is basically a placeholder that tells the script that a certain value will be filled in later. So let's come back over to our text editor and replace the spot where we used a dot to refer to the current directory with a $1. The $1 is the placeholder, and it's going to tell the script to look for some additional text after the name of the script when we run it. To be consistent, let's also replace the word current up in our echo line with the $1. And then we'll take a look at how this actually works. So I'm going to save my script file again, come back over here. I'm going to clear my screen just so it doesn't have as much clutter, and run that findexec.sh script command again. And when I run it, it works pretty much the same. The only difference is the word current is missing from our first output line, but it still shows files in the current directory. However, now if I type /findexec.sh space /users usr /local and run the script, I'll get a listing of executable files in the /user/local directory and its children. So I can now search for executable files in any directory on my system without changing any of the code that I wrote in the script. So let's look at what happened here. When I wrote the command to run it, I included after the command some additional text, the /user/local up here. Even though it's wrapped around onto two lines on my screen, that's really just a single term. There's no spaces in it. When the bash shell goes to interpret the script, at the time that I run it, it takes any instances of $1 and replaces it with the first thing that I wrote after the name of the script. And so it just replaces $1 with /user/local, where I told it to do echo, and it replaces $1 was /user/local, where I told it to do find. So this is what enables me to use a script with a replaceable parameter. This is incredibly helpful. It's something you'll use throughout the semester, and in fact you'll be using it in your first homework assignment for this week. This script is very simple, only 2 lines of actual code that get executed. We have our comments and then 2 lines. The script just goes through and skips the comments and then starts executing each line one by one. And as you saw, that works just fine. And this is all we're going to do for the script for this semester. A lot of times scripts are actually fairly short, so we just combined a couple of commands, simple commands, into a single script file. Thanks for watching.